Good day, students. Welcome to our pre-calculus class again. Today, we're going to talk about conics at large, foci, directrices, and eccentricity. The graph of an equation of the form ax squared plus by squared plus cxy plus dx plus ey plus f equals 0 is one among a parabola, an ellipse, a hyperbola, or a degenerate conic. Focus directrix property. The locus of all points in the plane, the ratio of whose distances from a fixed point F and a fixed line L is a constant E, is a parabola if E is equal to 1, an ellipse if E is greater than 0 but less than 1, and a hyperbola if E is greater than 1. E means eccentricity. The eccentricity of a conic is the constant ratio E above. The fixed point F is the focus of the conic. The fixed line L is a directrix corresponding to the focus at F. A parabola has one focus directrix pair. A central conic, example an ellipse or a hyperbola, has two focus directrix pairs. If A, B, and C are the constants in the equation of an ellipse or a hyperbola in standard form, did you remember those A, B, and C? The vertices in the foci there at hyperbola or ellipse. Then E, or the eccentricity, is equal to C over A, or the eccentricity is equal to the distance between the foci over the distance between the vertices. The distance of a directrix from its corresponding focus is given by D is equal to B squared over C, or is equal to the absolute value of A over E minus A times E. Well, the distance of a focus from the center is C is equal to A times E. And the distance of a directrix from the center is A over E equals A squared over C. So you have to take note of those different formulas. The eccentricity of a conic describes its shape. A, approximately 0, conic is almost a circle. If E is greater than 0 but less than 1, or E is approximately 1, it's a very thin ellipse. And if E is equal to 1, that's a parabola. If E is greater than 1, or E is approximately 1, very thin hyperbola. And if E is very large, it's a very wide hyperbola. Okay, example number 1. Determine the graph of the given equation. The first one is 4x squared minus 4y squared minus 32x plus 8y plus 124 equals 0. The second, x squared plus 4x plus 4y minus 8 equals 0. And last, 25x squared plus y squared minus 100x plus 6y plus 190 equals 0. So we're going to determine what is the graph of that. Is it a parabola, an ellipse, or a hyperbola? Okay, we will go to the solution for the following. Let's start with number 1. 4x squared minus 4y squared minus 32x plus 8y plus 124 equals 0. The first thing that we're going to do so that we can solve the given equation is we simply complete the squares in the given equations. We can actually divide first both sides of the equation by 4. Because what have you noticed with the coefficients of the different variables there? We have 4, 4, 32, 8, 124. And those are divisible by 4. So we need to divide. 4x squared divided by 4 is x squared. Negative 4y squared divided by 4 is negative y squared. Negative 32x divided by 4 is negative 8x. And positive 8y divided by 4 is positive 2y. And positive 124 divided by 4 is positive 31 equals 0. And then we need to group those terms with the same variables. So, ang parehang variable, we have x squared and negative 8x. So, we have to group them so that we can complete the square later. Then, minus, okay, we have also y squared and negative 2y. Then, that's another group. It's equal to negative 31 because we subtract 31 both sides. And to complete the square, remember the formula that we're going to use. The half of b squared. Or you get the 1/2 of the coefficient of x. So whatever number that is the coefficient with x or the y, you have to get the half and square it. Since the first group with variable x, we have x squared minus 8x. And together with variable x, or the numerical coefficient of x, we have negative 8. So we need to get the half of negative 8, and that is negative 4. And we need to square it. So negative 4 squared, or negative 4 times negative 4 is positive 16. So we have a perfect square trinomial now. X squared minus 8x plus 16. So that's a perfect square trinomial, and we can complete it. We can complete the square now. We can have the factor that is the square of binomial. And we will proceed to the next group, which contains the variable y. We have y squared minus 2y. We need to get the half of the coefficient of y. So 1/2 of negative 2 is negative 1, and we need to square it. Negative 1 squared, or negative 1 times negative 1 is positive 1. So that is why we have y squared minus 2y plus 1. And since we added 16 and 1 at the left side of the equation, we also need to add 16 and 1 to the right side of the equation. So we have negative 31 plus 16. We need minus 1 here because there is negative before the group which contains the variable y. So we need to multiply it. Negative times positive 1 is negative 1. So we have negative 31 plus 16 is negative 15, minus 1 is negative 16. So we have negative 16 at the right side of the equation. And at the left side, we have to factor the perfect square trinomial. So the factor of x squared minus 8x plus 16 is x minus 4 squared. Or the square root of x squared is x. And the square root of 16 is also 4. Since the middle term, negative 8x. So we have x minus 4 squared. Minus the square root of y squared is y. And the square root of 1 is 1. And the middle term is negative 2y. So we use negative. So our binomial factor is y minus 1 squared equals negative 16. And as we know that if that is the given equation, so we can have the graph that is a hyperbola. Number 2, we have x squared plus 4x plus 4y minus 8 equals 0. So completing the square for x only, we get, since there is no y squared, so we need to complete the square, those with variable x only. So we have x squared plus 4x plus 4y, and we need to add 8 both sides. So negative 8 plus 8 is equal to 0 plus 8. It's addition property of equality. Whatever you add or you subtract or you multiply or you divide, the left side of the equation is the same you have to do at the right side of the equation. So we have here, we need to complete the square. We have x squared plus 4x. Since the coefficient of x is 4, so we need to get the half of 4. So 1/2 of 4 is 2, and we need to square it. 2 squared is 4, since 2 times 2 is 4. So it's a perfect square trinomial now. We have x squared plus 4x plus 4 plus 4y. So we add 4 at the left side of the equation to make it the perfect square trinomial. So we need to add also 4 at the right side of the equation. That is why we have 8 plus 4. And we need to get the factor of that perfect square trinomial, x squared plus 4x plus 4. And that is the square of binomial. So the square root of x squared is x, and the square root of 4, which is the last term of the perfect square trinomial, is 2. And we have plus here because the sign of the middle term is positive. That is positive 4x. So our binomial factor is x plus 2 squared plus 4y equals 12, because 8 plus 4 is 12. And the graph for that, because that's an equation of a parabola. So the graph is a parabola. Then number 3, 25x squared plus y squared minus 100x plus 6y plus 190 equals 0. So before completing the square for both variables, we factor out coefficients of the square. So since we have 25x squared and negative 100x, they have the same variable, so we need to put them in one group. And we have also positive y squared and positive 6y in another group because they have the same variable. But 25x squared minus 100x can be factor. Their greatest common monomial factor is 25. So we need to put 25 outside of the quantity sign. So we have 25 and then x squared, because 25 times x squared is 25x squared. And we have negative 4x because negative 100 divided by 25 is negative 4x. So that's the factor for 25x squared minus 100x. Plus y squared plus 6y equals negative 190, because we subtract 190 both sides of the equation. That's subtraction property of equality. And we need to complete the square now. So we have x squared minus 4x. Since the coefficient of x is negative 4, so we need to get the half of negative 4. So the half of negative 4 is negative 2, and we need to square it. So negative 2 times negative 2 is positive 4. That is why we have 25 times x squared minus 4x plus 4. And we have also the half of 6 is 3. And we need to square it. So the half of 6 is 3. So 3 squared is 9. Because 3 times 3 is 9. So we have y squared plus 6y plus 9. And those are perfect square trinomial already. But whatever we add at the left side of the equation, again, is the same number we need to add at the right side of the equation. Okay, since we added 4 and 9, so we need to add numbers also at the right side of the equation. It becomes 100 because 25 times 4. There is 25 before the perfect square trinomial x squared minus 4x plus 4. So 25 times 4 is 100. That is why we need to add 100 and 9. So negative 190 plus 100 is negative 90. Plus 9 is negative 81. Since they are perfect square trinomial na, so we need to find their binomial factor. So we have 25, and the square root of x squared is x, and the square root of 4 also is 2. And the middle term is negative for x, so we have minus x minus 2 squared. So that is the factor for x squared minus 4x plus 4. And also the square root of y squared is y, and the square root of 9 is 3. And we need to put plus or positive because the middle term is positive 6y. So we have the factor for those perfect square trinomial with the variable y is y plus 3 squared equals negative 81. Unlike in the first item, the left-hand side here is a sum, not a difference of squares, and hence cannot be negative. Thus, the graph of the equation is the empty set. You cannot tell it if that is a hyperbola, that is a parabola, that is an ellipse, or a circle. So that's an empty set. We have a theorem here, the focus directrix property. The locus of all points in the plane, the ratio of whose distances from a fixed point F and a fixed line L is constant E, is, okay, you have to take note of this. A parabola if E is equal to 1. Again, what is the formula in getting the eccentricity? We have C over the A, or the distances between the focus divided by the distances between the vertices. So, if E is equal to 1, it is a parabola. If E is greater than 0 but less than 1, that's an ellipse. But if E is greater than 1, that's a hyperbola. Again, if E is equal to 1, that's a parabola. If E is greater than 0 but less than 1, that is an ellipse. And if E is greater than 1, that is a hyperbola. Okay, example number 2. Determine the eccentricity of the conic with equation 4x squared minus 4y squared minus 32x plus 8y plus 124 equals 0. Since all the terms is divisible by 4, so we need to divide both or each term by 4. So 4x squared divided by 4, that is x squared. Negative 4y squared divided by 4 is negative y squared. Negative 32x divided by 4 is negative 8x. Positive 8y divided by 4 is positive 2y. And positive 124 divided by 4 is 31. And 0 divided by 4 is 0. So we have here x squared minus y squared minus 8x plus 2y plus 31 equals 0. And we need to group them. So we have x squared minus 8x, and the other group is we have minus y squared. It becomes minus 2y because we have negative before the given the given binomial. And we have here negative 31 because we subtract 31 both sides of the equation. And now we have x squared minus 8x, the first group with variable x, minus y squared minus 2y, the other group, equals negative 31. And we will complete the square. Okay. Since the numerical coefficient of x, or ang number nga kauban sa x, is negative 8, so we need to get the half of negative 8, and that is negative 4, and you need to square it. That's the constant formula in completing the square. You need to get the half of the coefficient of x and square it later. So the half of negative 8 again is negative 4 and square. Negative 4 times negative 4 is positive 16. So that is why we add 16. So x squared minus 8x plus 16 is a perfect square trinomial. And we will go to the y group. Since negative 2 is the numerical coefficient of y, or kauban sa y, so we need to get the half of negative 2. So the half of negative 2 is negative 1, and we need to square it. Negative 1 squared is the same with negative 1 times negative 1. Negative times negative is always positive, so we need to add 1 at the y group. So we have y squared minus 2y plus 1. It's already a perfect square trinomial. So we add 16 and 1. And at the right side of the equation, we have negative 31. So negative 31 plus 16, y minus 1, because there is negative sign before, y squared minus 2y plus 1. So negative times 1 is also negative 1. And we already saw in the first example that the equation can be transformed into the form, okay, x minus 4 squared, because that's the binomial factor of x squared minus 8x plus 16, minus y minus 1 squared. That's also the binomial factor of the perfect square trinomial y squared minus 2y plus 1 equals negative 16, because negative 31 plus 16 is negative 15 minus 1 is negative 16. And we can transform that to an equation of a hyperbola. So we need to make it in standard form. We need to divide 16, negative 16 I mean. So we have x minus 4 squared divided by negative 16 minus y minus 1 squared divided by negative 16, and negative 16 divided by negative 16 is 1. And we can put the positive result as the first. So we have y minus 1 squared over 16, because negative 1 divided by negative 16 is positive. And we have also x minus 4 squared over negative 16 will be negative x minus 4 squared over 16. And negative 16 divided by negative 16 is 1. And that's the standard form of the given hyperbola. So we just have A and B. Since the denominator of y minus 1 squared and x minus 4 squared is same, 16, and that's the value of a squared and b squared. So a and b are equal. So that's 4, because the square root of 16 is 4. Hence, since this is a hyperbola with c is equal to the square root of a squared plus b squared. So did you remember that in the hyperbola topic? To get the c, you need to get the square root of a squared plus b squared. So since the same ra ang value sa a squared of b squared, parehas lang 16. So 16 plus 16 is 32. So what's the square root of 32? 32 is not a perfect square trinomial, but still we can simplify it. 32 can be factored, which is 1 one factor is the greatest perfect square trinomial and the other one is not. So, di ba, ang factor sa 32, we can have 16 times 2. And 16 is the perfect square trinomial. The square root of 16 is 4. And the other factor, which is 2, is not. So, just put it inside the radical sign. So, square root of 32 is the same with 4 square root of 2 because we have simplified it. Thus, the eccentricity of this hyperbola is E is equal to C over A. Since our value of C is 4 square root of 2 and our value of A is also 4, so 4 square root of 2 divided by 4, we can cancel out 4. So we can have the final answer, square root of 2. And that is 1.414 approximately. So we have E is greater than 1. So if E is greater than 1, that's a hyperbola. Do you remember this theorem? The focus directrix property? A parabola if E is equal to 1. An ellipse if E is greater than 0 but less than 1. And a hyperbola if E is greater than 1. So our E here is 1.414 because that's the square root of 2. So that's greater than 1. So that equation is a hyperbola. Classifying a conic from its general equations, the graph of ax squared plus cy squared plus dx plus ey plus f equals 0 is one of the following. So those a, c, d, e, f there are numbers, real numbers. So circle A is equal to C. And if A is not equal to 0, then that's a circle. Then A times C is equal to 0. A is equal to 0 or C is equal to 0 but not both. So that's a parabola. And ellipse. So we have A times C is greater than 0. A and C have like signs, so that's an ellipse. And it's a hyperbola if A times C is greater than 0 and A and C have unlike signs. So that is how to classify a conic from its general equations. So we will go to the historical gem. We have points at infinity, the birth of projective geometry. Indeed, the concepts that unite the conics are those of the focus, directrix, and eccentricity. However, while all of them appear in the treatment of any conic, there is a difference in the way they appear when considering a parabola in contrast to a hyperbola or an ellipse. A parabola has only one focus and thus also one directrix. Johannes Kepler suggested something bizarre during his time. Maybe the parabola also has two foci. We just cannot see the other one perhaps because it's too far away. French engineer Gerard Desargues took this seriously and suggested that the invisible focus was a point at infinity, a point at which the principal axis of the parabola meet all other lines parallel to it. The point at infinity was imagined to be the point at which parallel lines meet. They seem parallel to us since we cannot see their point of intersection, which is so far away. With the addition of these points at infinity to every line, a novel geometry was born, a geometry where all lines had a point of intersection. This is now called the projective geometry. With this, Desargues was able to authentically unite the conics. He is even able to consider a cylinder a cone as well. one whose vertex is at the point at infinity. So for integration of faith and learning, like the birth of projective geometry, it has points at infinity. God's love for us is infinite. No matter who we are, He loves us unconditionally. The Bible says in John 15:13, greater love hath no man than this, that a man lay down his life for his friends. So that's all for our topic today. May you learn something. God bless.